In this video, let us see about the matrix multiplication by using the dynamic memory allocation. So say that we have to multiply two matrices and the matrix size is 2 cross 3 for the first matrix and 3 cross 3 for the second matrix. Whether the column size of the first matrix is equal to the row size of the second matrix. So if both the sizes are equal, then we can multiply both the matrices. So what is going to be the size of the resultant matrix is the size of the first matrix row and the size of the second matrix column. So it is going to be 2 cross 3. So the resultant matrix size is going to be 2 cross 3. Hope you can recollect how do we perform the matrix multiplication. So we multiply the rows of the first matrix with the columns of the second matrix. So 1 into 1 plus 2 into 0 plus 3 into 1. So we get the answer for this particular cell as 4. So this is how the matrix multiplication is performed. Now let us see the matrix multiplication implementation using the C program. So first let us include the header file. So hash include stdio.h, and as we are going to perform the matrix multiplication by using the dynamic memory allocation, so we have to include lib.h. Once you include your header file, now we have to write down the main function. So int main of. So within the main function, now let us initialize a variable, say row 1, column 1, and the rows 2 and columns 2. So this is the row and column size for the matrix 1, and row 2 and column 2 are the size for the matrix 2. And let us initialize a variable I and j. And now let us first get the dimension for the first matrix from the user. So let us ask the user to enter the number of rows and columns for the first matrix. So we get the input from the user through a scanf statement for the first matrix. So ampersand row of 1, ampersand column of 1, and as it is an integer, we use the control string %d. So once we get the dimension for the first matrix from the user, now let us allocate the memory dynamically for the first matrix. First, we should allocate the memory for the rows of the first matrix. Say, for example, so this is the matrix, this is the matrix 1. So first we allocate the memory for these rows, say 1, 2 and 3. And then we will be allocating the memory for the column of the first matrix. So in order to allocate the memory for the row, we are supposed to use the double pointer. Then let us allocate the memory for the first matrix. So when we have to allocate the memory, first let us initialize a variable first matrix as a double pointer. So here, how do we allocate now the memory by using the malloc? We write down the data type asterisk, then the malloc. Within the malloc function, we have to specify what is the size of the rows of the first matrix into the size of the data type. So as there is a double pointer, we have to use a single pointer within the size of operator. Now we have created now for the rows. Now for every row of the first matrix, so for every row now we are supposed to allocate the memory for its column. So how do we allocate the memory for its column? A for loop. So for I equal to 0, I lesser than, for all the rows of the matrix 1, we now allocate memory for the rows of the first matrix. So how do we allocate now for all the rows of the first matrix? So first matrix of I now is equal to the data type. So int star malloc function. Now for every row, for the column, we are allocating the memory. So it is the column size of the first matrix into the size of int. So now automatically the memory will be allocated for the first matrix both for rows and columns. Now let us get the first matrix element from the user. So how do we get the first matrix element? So we have to get the element for the first matrix by using a double for loop. So for I equal to 0, so I lesser than row 1, I plus plus. Then for j equal to 0, j lesser than the column size. And now getting the first matrix element through a scanf statement, scanf percentage first matrix of I and j. Now let me show you how does this for loop executes. Let me explain you the dry run. So first I value is going to be 0. Now checking for the condition whether 0 is lesser than the row 1. So say that we are initializing the row 1 as 2. So let us now first write down the size of the row. So say that the rows 1 is going to be 2, and let us assume that the column 1 size is 3. So row 1 size is 2 and column 1 size is 3. Now let us see how does this for loop execute. So I equal to 0. So checking 0 is lesser than row size 1. Yes, 0 is lesser than the row size 1. Now it will get inside the loop. So now j is equal to 0. Now j, checking for the condition whether j is lesser than the column 1. So whether 0 is lesser than the column 1, 0 is lesser than 3. Yes, your condition is true. Now we will get inside the statement. Now we will ask the user to enter the value for the first matrix. So it will get the value for the first matrix as the first matrix of the value for I and j, which is going to be 0 and 0. So now we ask the user to enter the first matrix element. Now in the same way, we have to increment now the value of what? J. So until and unless your j loops gets completed, the value of the outer loop will not be incremented. So now incrementing the value of j. So j is going to be 1. Now j, checking out for the condition. So how do we check out? So j is equal to 1. Now 1 lesser than 3. Yes, 1 is lesser than 3. Now it will get inside the loop. And now it will get the value for the first matrix of 0 and 1. So 0, 1 will be obtained from the user. Now again your j value is going to be incremented. So j value is going to be 2. And now checking for the condition. So whether the 2 is lesser than 3. Yes, 2 is lesser than 3. So now you can get the input from the user. So first matrix of 0 and 2. Now incrementing the value of j as 3. So the condition fails here. 3 is not lesser than 3. So now it comes out of the loop and the value of I will be incremented. So now what will be the value of I? I will be incremented to 1. Yes. So now we have got for all the values of the rows of the first matrix, right? So if this is the matrix, so now we have got the element for 0, 0, 0, 1 and 0, 2. So the entire row element of the first matrix is obtained from the user. Now again incrementing the value of I. So let us now continue with it. So incrementing the value of I is equal to 1. So what is our role? So checking for the condition whether, so let us have this code. So checking for the condition I is equal to 1, whether 1 is lesser than the row. What is your row 1? Row 1 is 2. The size of the row is 2. So whether 1 is lesser than 2. Yes, your condition is true. Now it will get inside the loop. Yes, now j value is going to be 0. So 0 lesser than your column size. Your column size is 3. Yes, your condition is true. Now it will get the input for the first matrix. So the input element for the first matrix will be obtained. So what is going to be the value of I and j here? I is 1 and for j it is 0. Yes, so same way the value of j is going to be incremented. So the value of j is incremented as 1 and checking for condition whether 1 is lesser than 3. Yes, it is true. So now the value of first matrix of 1, 1 will be obtained from the user. Now again incrementing the value of j. So j value is going to be 2, whether 2 is lesser than 3. Yes, 2 is lesser than 3. Now it will get the input from the user for the first matrix of 1 and 2. Yes, okay. So now let us increment the value of j by 3. So 3 lesser than 3. No, 3 is not lesser than 3. Now let us increment the value of I. So I value is incremented now to 2. So I value is equal to 2. Now check for the condition whether the value of I is lesser than the row 1 size. Whether the value of I2 is lesser than, what is the row 1 size? Row 1 size is 2. No, the condition failed, so it will not get inside the loop. So now we have got the input for the second row of the first matrix. So that is for 1 0 1 1 and for 1 2. So once after you enter the element of the first matrix, now similarly let us get the dimension for the second matrix from the user. Now in the same way as we have got the size of the first matrix from the user, in the same way we can get the dimension for the second matrix from the user. So let us get the dimension of the second matrix from the user. Let us ask the user to enter the rows and the column of the second matrix. Say it is by using the variable rows of 2 and columns of 2. So once the dimension is obtained from the user, now we have to allocate the memory for the second matrix. So in the same way, we have to create a variable which is a pointer to pointer variable, double pointer, and allocating the memory. So hope you can remember the syntax now. So the data type, double asterisk, malloc. First we will create the memory for the rows of the second matrix. So say that this is your second matrix. So first we will be creating the second matrix row. So this is the memory for the second matrix. And once we create the memory for the rows of the second matrix, let us now for each rows of the second matrix, for I equal to 0, for I lesser than all the rows of the second matrix, we have to now allocate the memory for its column. So how do we allocate the second matrix of I is equal to the data type malloc, the column size into the size of the data type, so that the memory will be allocated now for the column of the second matrix for every row. So this is how the 2D memory allocation is done by using the malloc function. So now getting the second matrix element from the user. So how do we get it? We have to run a double for loop and getting in the same way as we have done for the first matrix. So ask the user to enter all the elements of the second matrix by using the double for loop. Now let us create the memory for the resultant matrix. So how do we allocate the memory for the resultant matrix is by the same way as we have done for the second matrix and the first matrix. So create a variable called result matrix, which is also a double pointer variable. Use the malloc function. So first allocate the memory for the rows of the resultant matrix, and then for every rows of the resultant matrix, allocate the memory for its column. So this is how we allocate the memory for the resultant matrix. So now as we have completed creating the first matrix is created, the second matrix is created, and we have allocated memory for all the three matrices, the resultant matrix first and the second matrix. Now let us perform the matrix multiplication. So here I'm going to create functions named as multiply matrices, and I'm passing the following arguments: the first matrix, the size of the first matrix, the row size, the column size of the first matrix, the second matrix, then the row size of the second matrix, the column size of the second matrix, and the resultant matrix. So now let us write down. So this is the function call. Now let us write down the function definition for this multiply matrix function. So we have to write this about the main function. So now how to perform the matrix multiplication. So this is a function definition for the matrix multiplication. So let me tell you one by one. So here as we have passed the argument, the first matrix, which is a double pointer variable, and the size of the rows of the first matrix, the size of the columns of the first matrix, and then the second matrix, which is a double pointer variable, and the size of the rows of the second matrix, then the columns of the column size of the second matrix, and the resultant matrix, which is also a double pointer variable. Now, first, what are we supposed to check out is whether the column size of the first matrix is equal to the row size of the second matrix. So as I have mentioned earlier, we have to check out whether the column size of the first matrix, which is 3, whether it is equal to the row size of the second matrix. So if both are equal, then I can perform what? The matrix multiplication. So first let us check out. So if both are not equal, now what do I throw? I should throw an error message that the matrix multiplication is not possible. Okay. Now, if both the size of the column of the first matrix and if the size of the rows of the second matrix both are equal, now let us write down the statement to perform the matrix multiplication. Use a for loop to perform the matrix multiplication. So first for loop has to be returned for the number of rows of the resultant matrix. So what is the size of the resultant matrix? So as I have mentioned earlier, the size of the resultant matrix is going to be the row size of the first matrix and the column size of the second matrix. So what is how do you mention the row size? The row size is of the row size of the first matrix. So row S of row S1 and the column size of the second matrix. So this is going to be the resultant matrix size. And initially we write down the resultant matrix of ij as 0. Matrix multiplication has to be performed for the column size of the first matrix and the row size of the second matrix, right? So it's going to be 3 and 3. So both are same. So now let us write down k lesser than the column size of the first matrix. So how do we perform? We have to now perform the multiplication between the first matrix of ik variable and the second matrix of kj variable. Now let us see the dry run for this entire code. So this is the code which we have for performing the matrix multiplication. So let us assign the value. Let us take the input. So row 1 as of now is 2. So let us take, for example, the row 1 size given by the user is 2, the column 2 is 3, and column 1 is 3. So now how does this loop executes? So let us write on the dry run for this. So for I is equal to 0. So first I is 0. Now let us check out whether 0 is lesser than your row 1 size. 0 lesser than, what's your row 1 size? Row 1 size is 2. Now it will get inside, your condition is true. So as your condition is true, it will get inside this loop. So now j value is going to be 0. Now j checking for the condition whether the j value is lesser than your column size of the second matrix. So column size of the second matrix is 3. Now checking for the condition, yes, your condition 0 is lesser than 3. So now what do we write? We write down that the resultant matrix is equal to 0. Okay. Now we'll get inside the for loop. So for k equal to 0. Now checking for the condition whether 0 is lesser than your column size 1. What is your column size 1? 0 is lesser than your 3. Now, yes, your condition is true. So once your condition is true, it will get inside the loop. So what does the loop states? So what is the statement within the loop? Now, the resultant matrix ij. So what is the value of I and j now? So let me just rewrite the statement is equal to the resultant matrix ij plus the first matrix of I k into the second matrix of kj. Now what will be the value here? So instead of I am going to write 0. For j, it is again going to be 0. Now what's the value of I and j again here? 0, 0. For I, it is 0, and for k, it is 0. So 0, 0. Now, second matrix is k and j. K value is 0 and your j is also 0. So k is 0 and j is also 0. So now what will be the value here? The resultant matrix 0, 0. Initially, it was assigned as 0. So 0 plus, what is your first matrix? First matrix 0, 0. So let us take out this example. The first matrix 0, 0. So it is this, the first matrix 0, 0 into your second matrix 0, 0. So this is the index. So we are multiplying this together. Okay. And this is stored in the resultant matrix of I and j, which is 0, 0. So here what is going to be the value? It is 1 into 1. So the answer here is 1. Now we have to increment the value of k. So only after this k loop gets completely executed, the value of j is going to be incremented. So now let us increment the value of k. So the value of k is incremented as 1. Now checking for condition whether 1 is lesser than 3. Yes, 1 is lesser than 3. Now it will get inside the loop. So getting inside the loop, the resultant matrix is going to be updated. So how do I update the resultant matrix of ij? So this is the formula. So the resultant matrix of ij, what is the value of I? I is 0 and j is also 0. And instead of, so in the place of k value, I'm going to update it as 1. So the first matrix of 0, 1 into the second matrix of 1 and 0. Now just look at this example. What was the answer for the resultant matrix of 0, 0 already? So it was 1. So 1 plus the first matrix 0, 1. So what is the first matrix 0, 1? The first matrix 0, 1 is going to be 2. And what is your second matrix 1, 0? The second matrix 1, 0. So it is, what is 1, 0? 1, 0 means that it is the second matrix first row's 0th column. So we multiply the first matrix 0, 1 element with the second matrix 1, 0 element. So the value here is 2 and 0. So 2 into 0. So what do we get here? As the answer is equal to 1. Now let us again execute. So k value is now being updated to 2. Now your value, checking for condition whether 2 is lesser than 3. Yes, your 2 is lesser than 3. Now let us update the resultant matrix. So the resultant matrix is updated here. So the value of k will be updated here. So 0, 2. The first matrix of 0, 2 with second matrix of 2, 0. So what is the value? So you will multiply 3 with what? The 1. So it is going to be, so what was the earlier value for the resultant matrix of 0, 0? It was 1. So 1 plus your first matrix 0, 2 value is 3 and your second matrix value is 1. So it's going to be 1 plus 3 into 1. Now we have found out the answer for the resultant matrix 0, 0 position. Now in the same way, we have to find for rest of the other. Now what is the next step that we have to do? So we have completed and now let us increment the k loop. So k is 3, 3 is lesser than 3. So the condition fails. Now it will come out of the loop, come out of the loop. Now the value of j will now be incremented. So the value of j is incremented. So how do you increment the value of j? So j value is equal to 1. Now again checking for the condition whether the value 1 is lesser than 3. Yes, it is lesser than 3. And now you update the resultant matrix. So you update the resultant matrix here as 0. And now getting inside the k loop as in the same way. So k value is going to be 0. And now checking for condition whether 0 is lesser than 3. Yes, 0 is lesser than 3. Now you update the resultant matrix as we have done in the same way. So once your k value is equal to 3, now it will come out of the loop. So once it comes out of the loop, so during this part, it will get the input for what? The rows of the first matrix multiplied with the second column of the second matrix, and we'll be able to get the answer for the resultant matrix of 0, 1. When we move on, the value will be incremented now to 2, and now checking out for the condition whether 2 is lesser than 3. Yes, 2 is lesser than 3. Now it will get inside the K loop. So before getting inside the K loop, the resultant matrix is now equal to 0. So coming inside the K loop, so K is equal to 0. Checking out for the condition whether 0 is lesser than 3. Yes, and now it will get the input, and now it will multiply, and the resultant matrix for the 0 2 is uptime, because the I value is 0 and your J value here is okay. The resultant matrix of 0 2 will be uptime. Now once we complete this, now J value will be incremented to 3. So J lesser than 3, if the condition fails, so it will come out of the loop, and now the value of I will now be incremented. So what is the value of I now? I was 0. So now we were in the 0th row. Yes. So we were in the 0th row. We found out the resultant matrix for the 0th row of the resultant matrix. And now our control goes to the first row of the resultant matrix. So now your I value will now be incremented. So I value is equal to 1, and you follow the same procedure what you have done for the previous row. So I value will be 1, and checking again 1 is lesser than 2, and now it will get inside the loop K loop. It will get the resultant matrix for the first row, first column. It's going to be the resultant matrix first for the 1 0, and so we'll be able to get the resultant matrix for 1 1 and for 1 2. So this is a dry run of the matrix multiplication. Now let us jump back into the code. So hope you have understood now how is this matrix multiplication being performed. Now let us write down the function now to print the matrix and to deallocate the memory which is being allocated by the malloc function by using the free. So how do I print the result? So write down a printf statement. The result of the matrix multiplication are, and I am calling a function called as print matrix and passing the result matrix, the size of the resultant matrix as the argument. What will be the size of the resultant matrix? It is going to be the row size of the first matrix and the column size of the second matrix. Yes. Okay. Now let us write down the function definition for the print matrix. So we have to write down about the main function. See the function definition part for print matrix, passing as argument the resultant matrix, the rows of the resultant matrix, and the columns of the size of the column size of the resultant matrix. So we have to now print the rows and the columns of the resultant matrix. So we have to use a for loop. So for I equal to 0, I lesser than the rows, and for j equal to 0, j lesser than the column, printing the resultant matrix. Okay. So once we print the resultant matrix, we are supposed to now deallocate the memory which is being allocated by the malloc function by using the free function. How do we do that is by using a function named as the free matrix, and we are passing the first matrix, second matrix, and resultant matrix as the arguments, and the size of the first, second, and the resultant matrix. So now let us see the definition here. The void free matrix. So as a first matrix is a double pointer variable, so we are writing down data type double asterisk the matrix, and we are passing the row size as the argument. Now I have to run the loop for all the rows in order to deallocate the memory allocated for all the rows of the first matrix. So freeing out the matrix, for all the rows, right? So for all the rows of the first matrix, I'm deallocating the memory. And once I deallocate the memory for the rows, now I'll again call a free function to deallocate the entire matrix. So in the same way, you have to now deallocate the memory for the second matrix. So again, you have to call the function uh, free matrix of second matrix and the size of the second matrix row. Once you pass, the control will come to this part. Again, the number of rows of the second matrix will be the memory which is allocated for all the rows of the second matrix will be deleted, and the entire matrix will be deleted by using this method. The same way for the resultant matrix. So this is how the matrix multiplication is being done. Now, hope that you have understood the code for matrix multiplication. Now, let us compile this code. There is no error. Now, let us run this code. So, we are supposed to enter the rows and column for the first matrix. Say that we are entering a 3 cross 2 matrix, and we are entering the element. So, 1, 2, 3, 4, 5, 6. And now let us enter the rows and column of the second matrix. Say that we are entering the a row and column of the second matrix as a 2 cross 3. So 2 cross 3. So the resultant matrix will be of size what? 3 cross 3. So let us now enter the element of the second matrix. Say I am entering as 1, 1, 1, 1, 1, 1, and the resultant matrix size is going to be a 3 cross 3, and the resultant matrix is being printed here. And this is all about the matrix multiplication by using the dynamic memory allocation.